Oh, welcome back to this random table where I fix stuff. Today we've got this probably the mid to late 60s Arvin AM FM radio, and supposedly this doesn't work. I haven't tried it myself yet. Pretty basic, just AM FM switch, and then they have a switch here for AFC volume and tuning. I don't know. This is a pretty funny. I think this tuning indicator is pretty funny here. Looks like they just put a disc like right on the front of the tuning capacitor. Actually, that's interesting. You can actually see the numbers do cycle around, so it's not directly on the front of the tuning capacitor, because you can see the AM numbers very faintly there. When I turn it over to this side, you can see the FM numbers very faintly. That's interesting. Take a look at the back. Like we've got, what, 5 tubes there? No, 6 tubes. There's one sideways. 35 watts. Date of manufacturer. I don't see the date of manufacturer though. Yeah, I don't see it. The only stamp I see is this, but that doesn't look like a date to me. Anyway, let's plug this in and see what it does. The bottom has nothing, so plug this in and see what happens. It should be off now. Yeah, keep it off, plug it in, and see what happens. Well, absolutely nothing so far. Oh, there's some noise. Not really getting anything though. Let's try AM. Nothing. Switch seems a little bit dirty, but doesn't seem to make any difference. Alright, first thing I'll probably do is clean this switch and see if that does anything. So we're getting absolutely nothing. Alright, so I'll take it apart, clean that switch for the first step, and see if that makes any difference. So, turn this back around the back. I think this thing just pops right off. And there's that. Actually, the cheater cord unplugs here. And it looks like we got an AM antenna on the back there, and then I just see one screw here. Is that the only thing that holds this in? Another screw on the volume control, it looks like, and there's one right there, and there's 2 on either side of the, I'm assuming that's the FM tuner box. Screwdriver here, so we can take this out real quick. I do with a longer screwdriver here, but I think this will work. I'm gonna put this so the shoes, so you have to switch out. He's hitting this IF transformer, which I don't really like. Not sure why they. I don't think it's the way they did, but this is what would have been a pretty cheap radio for the time, so you can't expect too much. But okay, and pull the knobs off the front, maybe. Alright, knobs are off, so this should, I think. Oh no, there is a screw in the bottom, I see it sticking up there. Right there, there's one. I'll screw that over back here. There's no knobs, but that's fine. It's also like half the size of the other ones. Rather odd. Now let's see if this will come out. Oh, there's one more up there I missed. Oh, there's two more actually. I missed this one here. And there's one here. Now let's see if this will come out. Nope, there's one more right here. Oh, that's all these. This video has like more screws than most videos I work on. Usually they just got like 4 screws holding the chassis, and this one's got a whole bunch of them. Alright, so this comes out. Speaker wires should be able to pull from there. Okay. So it's out now. Of course, it's a series string set. You can see there's no power transformer, so we gotta see how I can show this. We got a circuit board, which is soldered to the speaker and soldered to the back. So, and I'm taking one of those off. See if we can look at the bottom. Because I got some shielding here under the one of the IF stages and this IF can. That plastic thing here broke off. I have to see where that went. Interesting. Looks like it was in the front because they got these stabilizers up here in the front. I'll show you. You can see that because my arm is in the way. Up here in the front, these things are just like little hooks like that. No one broke off, and just like hold the circuit board in place. So you can glue that back on. So there's a whole lot to this, honestly. I mean, there's going to be some, some fancy coils and stuff here in the FM box, but I don't think that's going to be our issue because AM doesn't work either. So, what could be wrong with this? I see a diode here that could be open. I see a power resistor that could be open. Although there was some noise, so there must be some kind of B plus. Didn't hear any hum, so I doubt it's the filter capacitor, and that's ice cold. So, and we only had it on for a little bit, but if it was significantly leaky, it would have gotten warm. So we can see any cold solder joints. This one here doesn't look too hot. It doesn't look cold. It looks like it was crappy from the beginning. Let me see anything obvious. So, this what I'll do is I'll check that diode, clean the switches in the front, and see if there makes any difference. I think the problem might be cold solder joints after all. They're just up in the front where I wasn't looking that close before. I was looking from the back. But these down here are the bottom of that board that has those switches on it. I'm not sure if you can see this, but there's quite a bit of significant play in that. It's really loose in there. So, oops. See if we can get a close look at those solder joints there. You can see the whole board move, so no way are those solder joints any good, and actually I can see gaps in those ones right there, so I'm going to solder those back up and we'll give this another try. I did clean those switches, by the way. Alright, so I resoldered those. I used a bit more solder than the factory originally used, so for those to be stronger and not break again. You can see now it's nice and stable, doesn't really wiggle at all. So let's flip this back over and power it up and see if there's any difference. Alright, so got this flip back over, we'll plug it in and see if it works now. So just looking at the overall build of this radio, I can see that mostly disc caps in here, and I think that's the only.
That's about $18,000.
That's definitely an improvement.
Enrolled for that senior class, which I think is a huge tip of the hat to our Imagine Prep seniors. This really.
Patriot app at your app store today.
This is AM, by the way.
Situation is embarrassing. You're listening. Where homes investment advisor right here. Let's call right now with your home improvement question or DIY.
Yeah, so now on the low one, let's go back up.
As if you. There, but very few.
In the local case.
Pranks.
Featuring Salem Rain.
Not for that for too long.
24-inch steel bar clamps.
That's pretty good for AM. Let's try out FM now. This volume control is all messed up because it didn't come in right away. Well, I doubt that would switch this tube off, so maybe you'll have to clean out that volume control a little bit too. Let's go all the way down to the low end.
Everything possible to help our customers through these uncertain times.
It's so weird. It's almost like it cuts out while tuning. I wonder if there's some dota or something in the tuning capacitor or something like that. I have to check into that then.
Outdoor recreation in our parks.
Are you happy? Well, stimulus. Both.
Hear that noise as I tune it?
That's how it feels to use.
Like a crackling noise almost. You can really hear it now when there's no stations. So check out to see if there's some dirt or something. I wonder how easy it is to take this cover off. It looks like it might just pop off the front. So I'll take that off and see if there's anything funny going on in there. Because AM seems to be fine, just FM seems to have this.
Speaker play Camel Country 1 is.
Yeah, see, it doesn't even want to tune now. I have to kind of coax it into tuning it. So yeah, I'll have to take a look at that. But otherwise, seems to be fine. Picks up plenty of stations on both AM and FM. Volume seems to be fine. See if this capacitor is getting warm. A little bit, but not a huge amount. Of course, it is right next to this power resistor and the output tube, so that's certainly not helping it. No hum though, so I'm not going to be particularly worried about it. So let me see if I can figure out what's causing that noise there. You can see how they did this dial pointer, and then it's regular like string drive off this for like drive reduction, and they just put a disc on the end of the shaft there. So you know what? That actually must be like a gear reduction drive. So that's one side and the other side. Yeah, so that is only actually like half a tone, but it's enough that it like overlaps on the. Oh, so yeah, that is just on the front of that then. So yeah, okay. Let me figure out what's going on inside there. So I managed to pop this off just enough to see inside there. I'm not sure if it's going to focus down in there. I don't know what I want it to. Doesn't seem to want to. Let's get closer. Oh, there we go. You can see, well, you could see for a second. If I can hold this steady. You can see that this almost looks like it's an inductive tuned FM. See, there's a coil of traces going down there, and then the wiper here, the wiper here slides along them. So that, to me, looks like inductive tuned. Those coil of traces is like a very low value inductor, and then as the tracers slide along it, it increases and decreases the inductance value. So that's interesting. I think they would have taken, a bit of circuit board engineering to get those traces to be like the right shape, to have the right inductance and everything. So kind of surprised to see it in, like a cheap radio like this. Usually like in TVs, only like the higher end stuff like the Dumonts, I think, use the inductive tuners, but I guess like once you get it engineered and like it works, then you can eliminate, the FM tuning capacitor. So like it would save money once you got it working, but I think it would have been pretty complicated to get those circuit board traces the right shape and everything. But anyway, that would explain why we're getting all that noise on FM. Those contacts must be dirty. So I'll clean those and we'll try it again. Alright, so I think that helped a lot. I don't really hear any more of that crackling now when I tune. So the only other thing that I see on here is that it's using a cup plate here for, I'm assuming, usually those are used for like the audio stage circuitry, and sometimes they have a capacitor inside that couplet that takes a signal from the audio driver to the audio output tube grid, and if that gets leaky, then you're basically cooking your audio output tube by putting a positive voltage on the grid. So I'm going to see if that's the case, try and trace out where the signal is coming into this tube from. This is the audio output tube here, by the way. And see if it comes from that couplet, and if so, I might end up trying to figure out what's inside there and rebuilding it, because otherwise, good chance you're probably going to cook this tube. So let me check that out. But otherwise, I think that's basically it for this radio. FMC is fine now, so like it works. It just, that's a preventative measure to prevent early failure. Okay, so I thought that maybe I should explain how an inductive tuner works. So usually, like in your radio or anything that needs like some kind of tuning, usually you have I call it like banana slicer capacitor like this, where you've got two sets of plates, one set fixed and one set motion, not fixed, one set that rotates, and see the plates mesh and unmesh, and as it happens, you vary the capacitance between them. So, like when they're fully unmeshed, there's these plates on top are, further away from the plates on the bottom, where there's less area where they're close together, which reduces the capacitance, versus when they're all the way meshed. Now there's a lot of area where the plates are close together, which increases the capacitance. And of course, in order for you to get a tuned circuit, you have to have a capacitor in parallel with an inductor. And usually the inductors for capacitors like this are just little coils like this right here. Or in the case of the antenna tuning, they'd be the big antenna coil here. So there's two ways you can change the resonant frequency of a tuned circuit. Either you can change the capacitance, which you can do with one of these variable capacitors, or you could change the inductance. Now some radios and TVs use inductive tuning by slugs, like car radios. So instead of having a variable capacitor like this in a car radio, what they do instead is they have a set of slugs like this, or a set of coils like this, where when you tune it, it moves the core, the slug, in and out of the coil, which as the slug is ferromagnetic, that also changes the inductance. When you've got the slug all the way in to the coil part, that increases the inductance of the coil, versus when you've got the slug, partially out or all the way out, that reduces the inductance due to the magnetic constant of iron or ferromagnetic material versus the magnetic constant of air. Just a material property. Another way, which some TV tuners use, is you can change the effective length of the coil, which looks like that's what they're doing in here. Now, it's not, because FM is so much higher frequency than AM, you need a lot less inductance to make a resonant circuit for FM. Like AM's like 55 or 550 kilohertz to like 1.7 megahertz, versus FM is 88 megahertz to 108 megahertz. So you need a lot less inductance and a lot less capacitance to make the resonant frequency for FM. So instead of having, a coil with lots of turns like this one has, you can get away with a coil with a lot less turns. Or in the case of what they've done here, and what some TV tuners do, is they have, just one or two loops of coil, and then to change the inductance, you're effectively changing how much of that coil is in the circuit. So like if we look in here, and what they may have done also is they may have a separate coil somewhere and then just have this tuning mechanism in series with that. So you get the inductance of that coil plus the inductance of this variable coil here. So you can see, like, when we go all the way down to the bottom, actually this would be all the way down to the bottom of the band, this would be the most inductance in this tuned coil, because it's the lowest frequency, so you need the most inductance to reach the lowest frequency. So then all of that loop of wire would be in the circuit, versus if we tune up the other way, see the wiper coming up there, that's good. Now only the distance between the end, which is over here, and the wiper, which is right here, that's the only distance of that loop that's in the circuit, so the inductance is decreased. And if we go all the way up to the end, it gets down to where there's very little of that trace there in circuit. So I'm thinking that they must have like some small coil in here in series with that. Otherwise, you know, when you turn all the way up, you're getting like 0 inductance, which is not going to work. So they must have that in series with another coil for the base inductance. So like that coil would be the correct inductance to tune to the high end of the band, and then as you tune down, you're adding the inductance of this trace, which increases the total inductance and then decreases the resonant frequency. So they would probably have to have a fixed coil in here and a fixed capacitor, and then the addition of this variable inductance here will modify the tuning. So I think that's kind of interesting. Usually you don't, at least I haven't seen it anyway on any of the cheaper stuff. Usually it's on the higher end, like higher end TVs and stuff like that. But anyway, it's kind of interesting. And like I said, they also use the slug-attuned FM in car radios, but they use it for AM too, actually. So anyway, I was able to pull up a schematic. It was pretty crappy. Like you couldn't read any of the text on it, but I could decipher enough from it to tell that the cup plate here is not. Let me show you. That this cup plate here is not in the audio circuit. It looks like it's just some RC stuff for the FM detector. So this capacitor here is actually the grid capacitor for this output tube. So we should be good there. I'm going to put this back together and we'll do one last test. And I think that'll be it for this radio anyway. Okay, we're all back together now.
Not weight loss. You know,
almost like the detail.
I'll like me and make my guy your guy. But what I have found to be
white supremacy until I.
That's FM. We'll switch to
LATAM Airlines Group and its affiliated airlines. Argentina, Brazil. Better way.
We'll walk.
She had this great God moment.
Some of the responses that
Your rate for the weekend at May 6th.
South.
Alright, so I think I'm going to be satisfied with that. There was a little bit of a rattle you might have heard in the cabinet, but it only happens when the volume is up higher than I would listen to it at, so I'm not going to worry about that. That's about it. This thing should be good then. So yeah, that's going to be about it for this video. Pretty simple fix. And Really, the only things that we used on this was some solder to resolder those connections to the switchboard, and the conduit cleaner for cleaning out that FM tuner. So, cleaning out the switches too. But that's gonna be it. So, hope you enjoyed this quick little video, and thank you for watching.